All right, welcome to another series in our uh, Security Plus course and also the cybersecurity module for the students at the university. Again, I'm going to do as I always use a slide deck, and please communicate with me if you need that. All right, so this is Chapter 9, Enterprise Architecture. There are two sub-modules in here. But again, that's my information. Please reach out to me on LinkedIn, YouTube, anywhere. I'm pretty much easy to reach. That's my bio again, in case you're not aware, right? It's copyright information. So in this chapter, we're going to basically try to hopefully help you learn how to describe what I call system vulnerabilities or weaknesses for you to be able to identify and contrast security needs of what we call common system architecture. So in module A, let me specifically look at common host-based vulnerabilities. That's like in your own system as opposed to server-based. And then describe and categorize malware, which just means malicious software. And so you have what are called servers and endpoints. These are basically the primary targets for attackers. You need to think about stuff like mobile devices, virtual machine, basically anything connected to your system. You need to figure out how to make it stronger to address weaknesses. So when we say the word system vulnerabilities, we're talking about not just applications, but the actual network vulnerability. So sometimes it's difficult to like separate them or build a boundary. Even social engineering or physical intrusion is just a basic way to access your system. So sometimes you're talking to people, they're like, oh, what are we talking about? System vulnerability. It's a very broad topic, but the whole idea is guarding against people the adversary trying to get into your system. So for attacks on our own host machines, it could be through applications that you run on your system, through your operating system, firmware, which is basically software embedded in the device, or drivers. Basically, drivers are applications or software that tells the operating system how to handle that hardware. And then hardware interfaces. All these are surfaces, or what I call attack vectors for the adversary. As relates to software, you have malware, open service ports, unpatched software, which means software that has not been updated to take care of known vulnerabilities, and even unauthorized systems and software. The hardware and the firmware, they also have their own vulnerabilities. It could be malicious software, altered firmware, spyware, which could be through software or hardware itself. Or how do you put a computer into an attacker control operating system? That's a concern. And of course, compromising a physically insecure network host, which means if it was a laptop, I didn't attach cable locks. Or in my server room, I didn't physically lock it so somebody can get in. We always say if somebody can physically touch a particular endpoint device or host, then they have more opportunity to compromise it. Security misconfigurations are also a concern for us. This could be anything from weak password or even no password on the system. You ask yourself, why would somebody not put a password? But trust me, I've seen that already before, right? Computers that are left unlocked or unattended, default credentials. This is a major thing. You get a router, you forget that the username and password is available on the internet. It could be admin or admin and password. You didn't change it. Also, giving regular users excessive privileges. We talked about the principle of least privilege in the earlier chapter. That's a major issue. And you should be able to log and track user activities on your network. Remember the AAA of cybersecurity, right? Authentication, authorization, and accounting. Just make sure that you're logging the activities. Legacy platforms. What legacy means older systems, older software, things that we're not really using anymore, or we're using it, but the original provider, the OEM or the software developer or company is not supporting anymore either because of end of life, right, or end of support. So anything from operating system apps or older computers, these are major issues. But sometimes entities don't have any choice because maybe they have specific applications that were designed to handle certain things and they cannot migrate, or they don't have, and they've not had enough time to migrate. So there's a joke here that many industrial devices rely on over 30-year ago PCs because they have custom software, and sometimes it's difficult to replace this. So legacy systems, while they have the functionality for the company, these are very serious security risk, because finding a way to secure them is a major challenge for cybersecurity analysts or security managers. When we use the word malware, it's two words, malicious and then software. They come in different forms: virus, worm, Trojan, bloatware like extra. Think about you as a person that I hate to use the word fat, so sorry. I don't want to offend somebody. If you're bloated, like, I have another visual, but I'm not going to say that. Anyway, or grayware, which fits between bad and good. Drive-by download, you go to a website and then you mistake it. Just like being on there, you download the malware. Logic bomb made to execute after certain conditions are meant as opposed to time bomb. And then removable devices, USB, these are major issues on there. But I think I have a separate topic on malware, but just understand these are general classification of malware. But malware, obviously, not just in terms of the classification, you need to have a vector to get into your system, which is usually by email or the removable devices that you just saw there. But it's going to have to carry something, right? Which we call the payload. So it could be like a backdoor to get into the system, the command and control, where it's sending something to another entity out there. Of course, botnet, which is just a robot network, taking all your different devices and put them into a network, right? And they behave like a zombie. Ransomware, this is what makes the news. Lock your system. I'm not going to give you access unless you pay me money. Spyware could be software or hardware, like the keylogger, physical one that we normally have. You attach it to your keyboard. And of course, hardware, annoying. And then browser security compromises, whatever the browser you're using. But how does malware hide? Because it's not just about seeing them. Sometimes it's difficult to detect them. So you have the polymorphic malware. You have the stealth malware. Think about the stealth fighter, fileless malware. Supposedly it doesn't attach a file. Or the rootkit, which are the stubborn ones that attach to maybe your operating system, or you boot in and it's right there. So that's how well they can hide. And many times malwares, they are written like in scripts, or you have what called malicious scripts. It could be PowerShell, Bash, Linux, Python, macros, even Visual Basic or JavaScript. That's why some systems, they disable the running of scripts, because they think that's a good way to take care of avoid malicious scripts, but it's a little more involved than that. All right, so I can also embed malware in images, pictures, right? Malware can be placed in like an image metadata, which is data about data. I'm sure we covered this, or if we didn't, check my forensics video on steganography, which is how you hide the information in like an image itself. Adversarial images can attack even the AI system used for image recognition and other data processing. This is a really, really good one out there, right? Attacking AI systems. Compromise the software and firmware. Remember, software is applications that we write. Firmware is application of software that is embedded in usually hardware. Even when you install your operating system, what's called a clean install, you might still have some malware in that critical business software. The drivers that we talked about before. You can also have, because of what I call supply chain vulnerability, you buy something, you think it's safe, but it's not safe because somebody has already infected it at the manufacturer's site. By the time it gets from there to you, it's already infected. I think SolarWinds. So what can we do for this situation? How do we defend against malware? Make sure that you get it from original equipment, the manufacturer, the original guys. Don't get it from third-party source. Check to make sure it's not altered. Look at things such as if you're loading a file, check the hash value. Make sure you have anti-malware software installed on your system, mostly on the host devices, but make sure you have some security on your network. Always install your security patches. Make sure you protect against malware in your network security features and have acceptable use policies, and definitely end user awareness training so that your staff knows what to watch out for. So I have this malware, and maybe I'm a security analyst or what we call a malware researcher. I can look at the behavior of the malware by putting it in what's called like a sandbox environment, like a safe environment, so I can study it. So you have what's called like heuristic way of looking at statistics, like the program code, or I just put it in what's called like an anti-malware engine where you run the program in an isolated environment. So you can basically see what it's doing. It helps you understand it. So you can maybe do reverse engineering. So whether it's on your host network or cloud, you can do sandboxing in all of those different environments to help you study the behavior for malware. So if you're doing the labs, there is a lab there, I think on the U35 platform about examining spyware. It's a pretty good exercise. So let's look at a few review questions to hopefully drive home our point. This is on system vulnerabilities. So here you have a configuration management tool that applies all Windows security updates, verifies that they're hardened to a security baseline. You've established that baseline, right? And you've identified non-approved applications. Which of the following vulnerability is it least likely to address? In essence, choose the best response, because all these are good response, and which one is the least likely one? Think about it this way. I can do certain things on my host. What can I not do on my host? So generally, firmware is difficult to detect, okay? Address, because most people don't patch firmware. Even what's called your BIOS or UEFI, you hear the word flashing the BIOS. Most people do not know how to do that. So it's easier to address the other ones than the firmware. Next question. The user logs into the computer and is presented with a screen showing a Department of Justice logo, indicating that the computer has been locked due to a user violating federal law. The system gives several details of the violation and indicates that you must pay a fine of $500 within 72 hours, or a warrant will be issued for arrest. Now, when you're reading this, it's beginning to sound like he's trying to mislead you into thinking it's like a Trojan. But pay close attention to the way the question is worded. The user cannot unlock the system. So what type of malware has likely infected the computer? Choose the best response. So this one, if I'm not going to be able to let you have access unless you pay me something, that's a ransom. That's where ransomware would be the good answer for this, right? But it can throw you off and you can say Trojan because it's something that looks like it's good, but it's bad, right? But the good answer here is ransomware, the best answer, sorry. Which kind of malware can spread through a network without any human interaction? Choose the best response. A worm is what propagates. I used to think about a worm. If you've ever been in a farm or somewhere, you see the worm on the ground, it's moving by itself, as opposed to a virus that maybe has to attach to a human or fowl, thinking about systems, right? All right. You've traced some anomalous network activity, which means something that is not normal, to a malware that has infected a whole department's computer. They are processing a distributed task using spare CPU cycles, communicating with a remote server, and sending emails to random targets. What kind of malware is it? Choose the best response. So you see, PUP, which is potentially unwanted program, that's just an annoying stuff. Spyware is meant to spy on your system. So Trojan is something good that is not really, but it's bad, right? Like Trojan horse. So here, when you see a lot of devices communicating with somebody else, all those devices have turned into like a robot, a zombie network, right? So that's why a botnet is this. Next question. You find a computer infected by stealth malware, meaning it's difficult to remove. The program installed itself as part of the computer's boot process to gain access to the entire operating system and hide from anti-malware software. What kind of malware is it? Choose the best response. I've taken a lot of certification exams, so when I'm doing this, as I'm going through the question, I am trying to see if I can figure out the answer without even looking at the 4 choices. So here I'm thinking, okay, stealth probably is going to be rootkit, right? Armored virus is like, think about an armored vehicle you cannot penetrate, right? So you're thinking about that's rootkit. It goes into part of the operating system and it hides from anti-malware software. That's part of the definition of a rootkit. All right, so let's go to module B, the second module here. So here I want to look at common deployment types. security benefits and challenges of what I call specialized architecture. And now we're going to look at the cloud deployment modules and the types and how they affect your enterprise security. Because remember, this chapter 9 is about enterprise architecture and enterprise security. So security controls for each system must be based on whatever the risk you think it's facing and how does it fit into your entire enterprise architecture, right? So even if it's Windows PC is telling you here, they face different risks and they need to be addressed or secured differently. Even if it's part of another information system, you need to secure them differently than if they were isolated, right? So different classification of how to structure your network. It can be centralized, it can be decentralized, it can be distributed, and it can have what's called serverless. So that's another way to think about it. The other way to look at it is how it's physically designed. So that would be, is it virtualized? Is it embedded or is it mobile? And then you can also see in terms of where it's located. Is it on premises? Is it co-location? Or is it with a service provider? And you have other modules like database, SOA, microservice, or operational technology, which we'll look at towards the end of this sub-module. But the whole idea is, whatever I'm trying to do in terms of my infrastructure, I need to think about, am I concerned about availability? Is it resilience to attack or failure? The cost, money is important, right? How responsive is it? How scalable is it? Can I go up and down? Ease of deploying it, which also relates to the skill of my staff. Risk transference, ease of recovery, patch availability, of course, power, and then computing resources that I'm thinking about. These are things I would think about in terms of how I'm going to structure my infrastructure. So centralized is also awesome because it's easy to monitor and maintain, but again, this is a single point of failure. Whereas the decentralized, you got multiple redundant points. It can be independent. It makes it more available and it has more resilience. So you can see on the centralized, I can manage it easier, but on the decentralized, I've got more resilience, right, and more availability. So virtualized architecture is a very common platform. One of the main goals here is to efficiently use steadily increasing computing power. Right, the two most common approach, like virtual machines, like Oracle VirtualBox, VMware, and containers, but they all have different arrangement. But the point is that, well, in either case, the physical computer is called a host, and then it runs virtualization software that try to imitate or emulate a specific environment. So you now have what's called an abstraction layer. So just remember that word in terms of abstraction. So virtual machines has their own like virtual system. They access your system resources through what's called a hypervisor or virtual machine manager. It says a monitor here, but it's managing the virtual machine. There are different types of hypervisors. It's type 1, which is the bare metal, and then type 2, which is hosted. All it just means is, am I putting it on top of the operating system or not? That's just the main distinction of them, right? So what do I need in terms of virtual network? I need, obviously, a network interface card to go out on the internet. But so I can just have one physical network, a NIC, and from that I can have multiple virtual NIC. But the hypervisor knows how to manage this. Has something what's called like a virtual virtual switch, right, to manage it. So every single virtualization platform contains some sort of virtual switch. Remember, switch is used to maintain a local area network LAN that doesn't really go outside. So here I'm just using a virtual part of it, right? Just like a virtual NIC, I'm having a virtual switch. Security benefits of virtualization and containerization means everything is easier to back up and transfer, right? Single physical or logical nodes, like if they're decoupled, I can replicate my task. I can have virtual desktop. I can deploy user workstation with remote access software. For containers, it's easy for deployment of applications and the components of my application. But along with the benefit, there are also vulnerabilities or weaknesses. So most of them you hear stuff like If it's a type 2, if I compromise the host, I'm going to have a problem with the hypervisor, which means maybe with the virtual machines. VM hopping can be used to attack other virtual machines. I hop from one to the other. You also have what is called a VM sprawl, where I'm just deploying a lot of VM because I don't have some kind of good way, like configuration management system in my enterprise to control who creates virtual machines. But you also have another concept that might come up on the exam, or you should know in general, what's called infrastructure as a code, or ISC. Basically, it uses machine readable files to generate and deploy whatever components you need in an automated process. It's almost like thinking about cloud session, but here is what it does is it takes your network design and deployment into like a software development project. So all of the risk of software development are just part of your network design. And insecurely developed code, again, is going to introduce a vulnerability into your cloud environment. So these are very good embedded systems here. They got everything inside there, like Raspberry Pi or Arduino. These are pretty cool, like little small ones. You can take it and you can just even connect it to your TV in your hotel or whatever, and you can do stuff in there. There's a special course on embedded system, but just know these have the software is embedded in them. But look at this. They relate to what I call RTOS most of the time, real-time operating system. They, just like Windows, iOS, or Mac OS, the benefit to this is they have instant response as data is received. So they have more like real-world deadlines, right? So different from what I just mentioned. And they're excellent for responsive devices that interact with like your physical environment, right? Such as your car. Your car system, most normal cars today, they have a RTOS in them. Medical equipment, even something like your pacemaker has an RTOS working in there. So they are based on usually Unix like kernels. So they have to work within tight tolerance, but that doesn't obviously mean that they are designed with security in mind. So just keep concerning maybe it's easier for me to attack your pacemaker than to attack Windows operating system. The point is, an RTOS is good for fast response as you get data. So now we used to have SCADA, supervisory control, and then ICS. Now we have this thing, we just call them OT, operational technology. So the ICS is used for like factory machines and distributed infrastructure, building automation system like HVAC or lighting system, fire suppression, your security system, that's part of BAS. Because we talked about the vehicle ones already, even aircraft or drones, actually, they have obviously systems in them, right? Of course, IoT devices, everything from your refrigerator, microwave, but they have network risk. Part of the issue is that they are often is called in the real world rather in a physically secured environment. They are specialized embedded systems. So they decrease attack surface, but they are usually designed with limited security. That's the first line in there. They are not hardened and they're not easily updated like their other IT counterparts, right? So you think of IT, information technology systems, right? So organizations sometimes don't take these OTs serious, but I think it's changing now. So this is more like older concept because most CISOs or CTOs or CIOs understand the danger posed by OTs. The IoT is expanding now here, Internet of Everything. This is a specific technology. It's not like a description of various technology. Camera, security system, utility meters, inventory, medical devices, all of these citywide sensor system. These are all part of IoT. So it's telling you here that whenever you see the word smart attached to something, it basically is talking about added IoT function, like smart city, IoT added function. Sophisticated devices, they have like large attack surfaces. So the whole idea is designed for compatibility and ease of use should not mean that you only think about default security. So now we should be having what's called a security by design from the original, not bolted in after the fact. All right, so let's switch gear and think about cloud architecture. So in terms of cloud architecture, The basic idea is that you have on-demand services, broad network access, resource pooling, rapid elasticity, go up and down, measured or metered services, some people say. But the main three service modules that you should be aware of is the SaaS, PaaS, and IaaS. SaaS, which is subscription-based, like your Gmail, Dropbox. PaaS, this is for maybe developers. You get the environment that you need to develop and host web-based application. And then IaaS is when you think about Amazon Web Services, Microsoft Azure. You have everything, low-level computing networks, such as network resources, storage devices, processing. Basically, your whole network, you can get it from a service provider. But this is a good diagram that distinguishes on-premises from the three service modules. Sometimes you have to say pieces as a service. On-premises, you're responsible for everything, right? But see, IaaS, PaaS, and SaaS, the blue section talks about who manages it, like the provider, the cloud service provider manages the bottom four in the IaaS, manages all of them in SaaS, and then of course manages the bottom seven in the PaaS. Just freeze on here and then see that, because this could be a good exam question. All right. So knowing the service modules, but how do we deploy them? You have basically four ways of deploying them: publicly, like AWS; private, like in the private entities like military and stuff; community, which would be like entities that share some things like chambers of commerce, law enforcement agencies, they can share to have a community cloud; and a hybrid, a combination of usually public and private. When you do hybrid cloud, you will hear terms, if you ever study for the cloud essentials or cloud plus, you need to know what's called cloud busting, which is I have a private cloud and I get to the level and I need to burst into the public cloud. But just look for one of my videos on cloud computing. But this, for now, this is all you need to know for purpose of the exam, and they might ask you what each one means. So if you have a definition, this is what's called whole low-hanging fruit in the exam. So with this now, the whole idea is, what is the definition of the word multi-tenancy? It just means I have, obviously, I can have an apartment, and inside my apartment, I have multiple people renting, right? So it's not necessarily, it says it's not binary. Like in IaaS, multiple tenants may be sharing the same physical cluster. In SaaS, multiple individuals logged onto the same web application is multi-tenancy, like everybody's using like Outlook or using, say, some accounting software. That would be the definition of multi-tenancy, right? This is a serverless architecture. Serverless architecture is very confusing or misleading. People think there are no servers. It just means that the servers are invisible. But so you got your host computer, host operating system, serverless runtime. But see this distinction. With serverless, I still need to think about security. It just means that the platform manages the server deployment, scalability. For serverless architecture, for example, I'm saying to you that new technology means more unknown risk, less available expertise to address them. The invisible server still has the same security risk. It just means you don't see that. So serverless computing is more reliant on automation and orchestration. But there is still a server. It's just telling you that for you, right? All right. So what are the risks with cloud security? I always tell people that the same security concerns for on-premises, you should have that also for cloud. It doesn't mean that because I'm operating on AWS, I don't need to think about security, right? It says still a network service and subject to network attacks. You need the internet to connect, right? So that means if I'm going to connect the internet, I have other security risk. So the additional security risk of integrating the two of them, you need to be aware of that. So you need secure communication. You need to make sure that your data all that is on the CSP is also encrypted and secured. Because see, if I attack public cloud services, they might affect several or even all customers at a time. If you heard, I think it was last week, I'm doing this November 2025, just a few weeks ago, there was downtime in the cloud service provider that affected everybody that was using that service. Just know that there are security risks attached to it, right? So what are the common vulnerabilities? It says common cloud vulnerabilities, APIs, password, encryption keys, security and compliance for cloud-based data, insufficient logging monitoring. These are like risk inherent to the CSP, right? So, but you still look at it as though you were doing it yourself. So these are like risks inherent by the nature of the cloud. So how do we secure our cloud resources? Whether you need to think about, of course, the BCDR, remember business continuity, disaster recovery, serverless architecture, encryption and key management, logging and monitoring, and some kind of collaboration tools. Now, if you're doing pen testing cloud services is tough because you need permission from the cloud service provider as opposed to on-premises, right? But maybe you need to, in your service level agreement or your contract with the cloud service provider, you need to have some kind of understanding about what are they doing to secure their environment so that you can make sure your data with them or your computing while you are in the cloud is secure. Cloud augmented security services, anti-malware, email security, content filtering, vulnerability scanning, as I just said, firewall and distributed denial of service protection, monitoring as a service. These are cloud-based security services that you can sign up for. Authentication as a service, AAS. So that's why I said you now have everything as a service, XAAS, right? So there is a lab about detecting vulnerability. But let's look at some questions in here. What are the advantages of distributed architecture over centralized ones? Choose all that apply. So if you distributed, are we thinking about cost, ease of deployment? Is it more resilient? Is it more responsive? Is it more scalable? So here, distributed is more resilient because you have different redundant ones, right? So if one fails, you can have another one. Sorry. It's scalable. I can add more. Right? You're deploying a cloud web application using a PaaS under shared responsibility. Which of the following layers will your organization be responsible for securing? Choose all that apply. Remember, I just showed you that I said the bottom 7 is the responsibility of the cloud service provider, right? So you need to be concerned about the application configuration and definitely your data. You're moving from some cloud-based applications, right? You're moving some applications, from your VMware to serverless architecture. Which element of vulnerability management is likely to change the list? It is not saying that it will not change. Which one is likely to change the list for you? Choose the best. So this is tough because they all should change, but it's just telling you that you still need to be aware of secure coding. Just because I'm going from VM to serverless architecture, I need to engage in secure coding practices. All right, you're planning a new security solution that involves installing software agents to monitor individual systems. Which system architecture is most likely to have problems with that? So which one of these is more difficult to monitor, right? And usually it's IoT because of the nature of their design. What's the main advantage an RTOS has over a typical workstation OS, like the one in your car, as opposed to, say, Windows operating system? Simple. They are responsive. That's part of the definition of RTOS, all right? So in summary, by now I've tried to describe common host and device vulnerability and malware threats. We looked at how to identify and contrast security needs of common system architecture based on maybe the physical design, network structure, and then their intended purpose. As always, please feel free to send me questions. I'm going to do chapter 10 next for those who want to see that. You don't have to, but please feel free to, again, like the video, share with people. I'm also doing this for those who cannot afford to buy the software, especially those in more, I call them emerging technologies, so they can at least understand the concept. Even if you're not going to take the CompTIA Security Plus exam, at least please understand this concept. You're going to be involved in cybersecurity. So thank you and stay blessed.